All right, let's take a trip. An absolutely epic one. We're going on a grand tour of our solar system, heading out to visit the colossal giants of the outer reaches. We're going to explore turbulent storms literally bigger than our entire planet, check out moons with hidden oceans, and tell the story of the incredible robotic explorers that showed it all to us.
So think about this. Back in 1977, humanity launched a message in a bottle, but not into an ocean, into the cosmos itself. These were the Voyager missions, and they were designed to take advantage of this super rare alignment of the outer planets, which basically let us visit all of them in one single shot. But their mission didn't stop there. Oh no. They were destined to become our silent ambassadors to the stars.
Now, we didn't go on this grand tour ourselves, of course. We sent our robotic proxies. These incredible machines became our eyes and our ears out there in the deep, cold darkness of space, and what they found would completely revolutionize our understanding of our own solar system.
You know, this whole journey didn't happen overnight. It was a race to the outer worlds that spanned decades. It really kicked off with Pioneer 10's flyby of Jupiter way back in '73. But the main event, the real headliner, was in 1977 with the launch of the twin Voyager probes. Their timing was perfect, allowing them to ride this gravitational wave from one planet to the next. And then, building on everything they taught us, the Cassini mission launched in 1997 for a really deep dive into the Saturn system.
Okay, first stop is the undisputed king of the planets, Jupiter. We're talking about a world of just immense scale, unbelievable power, and a kind of turbulence that has fascinated astronomers for centuries.
So, what's this king of planets actually made of? Well, it's mostly hydrogen and helium. Yep, the very same stuff that makes up our sun. It is so massive, it could literally swallow all the other planets in our solar system whole. We've sent a whole fleet of probes, from Pioneer to Juno, and they've shown us a world of just raging storms, an incredibly powerful magnetic field, and a family of nearly 80 moons.
You can't talk about Jupiter without talking about its most famous feature, the Great Red Spot. Now, you might look at it and think, oh, it's a hurricane. But it's actually the exact opposite. See, hurricanes on Earth are low-pressure systems, and they burn out after a few weeks. The Great Red Spot is a high-pressure storm, wider than our entire planet, that has been churning away for at least 300 years.
Jupiter storms are, incredibly impressive, but they're driven by something even more powerful lurking deep, deep inside. The planet generates a magnetic field so huge it just dwarfs our own. So, what in the world is the engine behind it?
The answer is just wild. Deep within the planet, there's a vast ocean of something called metallic hydrogen. The pressure down there is so immense, we're talking millions of times greater than on Earth, that it literally crushes hydrogen gas into a flowing, electrically conductive liquid. It's this churning metallic ocean that generates Jupiter's colossal magnetic field, a field so big it actually stretches all the way to Saturn's orbit.
And as mind-blowing as Jupiter itself was, what Voyager found orbiting it, well, that just changed everything. These weren't the dead, boring, cratered moons we expected to see. Not at all. They were dynamic, active worlds of fire and ice. First up, you've got Io. Look at this place. It is, without a doubt, the most volcanically active body in our entire solar system. It's constantly being squeezed and stretched by Jupiter's massive gravity, which heats its interior and powers hundreds of volcanoes. They erupt so often that any impact craters just get buried under fresh lava almost immediately, which leaves its surface looking weirdly smooth. And then right next door, you have Europa, which is a totally different story. It's a world of ice. Its surface is this fractured, cracked shell, but all the evidence we've gathered strongly suggests that beneath that ice lies a massive, global ocean of liquid salt water. A hidden ocean, so far from the sun, making it one of the most compelling places to go looking for life.
All right, leaving the king of planets behind, our next stop on the tour is the absolute jewel of the solar system, Saturn. And while it's famous for those magnificent rings, the real wonders of Saturn, they're in the details.
So here's a little puzzle for you. Jupiter is way more massive than Saturn, right? But it's also significantly denser. Now, they're both made of roughly the same stuff, hydrogen and helium, so how does that work? How can the bigger one be denser?
It all comes down to one thing, gravity. Jupiter's insane mass creates this incredible gravitational squeeze on its own core. Imagine you have two sponges, one big and one small. The larger sponge's own weight is going to compress it more tightly. Well, it's the same thing with Jupiter. All that extra mass just packs the same material into a much, much denser space.
And you can see this delicate dance of gravity playing out perfectly in Saturn's rings. The biggest gap, the one called the Cassini division, you can even see it from Earth. Now, it's not totally empty, but it's kept clear by the constant gravitational tug of the moon Mimas. Mimas basically acts like a cosmic shepherd, herding all the little ring particles out of its path.
But maybe the most intriguing place in the Saturn system is its moon Titan. It's the only moon in our solar system that has a thick atmosphere. And what's really remarkable is that it's mostly nitrogen, just like Earth's. But on Titan, the small bit of methane creates this bizarre weather cycle where it rains liquid methane, which then flows into rivers, lakes, and seas of methane. It's like this eerie, freezing reflection of our own world.
Okay, we're heading way out now, to the far reaches of the solar system. Our journey is taking us to the mysterious ice giants, Uranus and Neptune. These frozen worlds have only ever been visited by one single spacecraft, Voyager 2. So when Voyager 2 finally flew by, the first thing that just hit everyone was their stunning colors, this serene aquamarine for Uranus, and this deep, vivid azure for Neptune. But what gives these two distant relatives their signature blue hue?
Turns out, the secret ingredient is methane. Now, there's still mostly hydrogen and helium, just like Jupiter and Saturn, but that little bit of methane gas in their upper atmospheres is the key. That gas absorbs the red part of the sunlight and reflects the blue part back out into space, and that's what gives them that beautiful color.
And just like that, our grand tour of the planets is over. But for the Voyager probes themselves, the journey was really just beginning. Their mission completely transformed as they left the planets behind and started heading for the stars. Decades after their launch, both Voyager 1 and 2 have now crossed into interstellar space, that vast, empty region between the stars. They are the very first human-made objects ever to do so, and they are still, to this day, sending back data, acting as our silent emissaries to the galaxy.
And bolted to the side of each Voyager probe is something truly special, the Golden Record. It's a time capsule from Earth. It's got images, sounds of nature, music from all these different cultures, and greetings in 55 languages. It's basically a greeting card to the cosmos, a snapshot of our world, sent out on the tiny chance that someone, someday, might find it.
And this brings us to one last, really profound thought. The chances of this record ever being found are, well, they're infinitesimal. But if it is, drifting through the galaxy billions of years from now, what story will it tell about its creators? What will they think of the species that reached for the stars and just wanted to say hello?